Hello everybody, welcome to Object-Oriented Programming with Java Laboratory video series. So in this video series, I'm going to explain the Java Laboratory programs step by step. So here you will get all the 12 programs, the explanation, code, and I'll show you how to execute the program in Eclipse IDE as well as in Sublime text editor. And you will, in the description, you will get the PPT which is related to the programs, and you will get the code as well. So first program is, so this is the syllabus. So here there are 12 programs in the Java Laboratory. The first program is quadratic equation. So write a Java program that print all real solution to the quadratic equation, that ax square plus bx plus c is the quadratic equation, where a, b, c are the the coefficient, and you have to use the quadratic formula to calculate the roots of a quadratic equation. Okay, so we will see what is quadratic equation and which is a quadratic formula to calculate the roots of a quadratic equation. So ax square plus bx plus c is equal to 0 is a quadratic equation where a, b, c are the coefficient, and the c, you can say c is a constant value. One thing you have to notice here is you cannot give the a value 0. A value of a cannot be 0, then your equation will not become a quadratic equation. Okay, so in this quadratic equation there are two roots. If you want to calculate the two roots, you have to make use of this formula, that is minus b plus or minus b square minus 4ac divided by 2a. By using this formula, you can find out the roots of a quadratic equation. Then, so the roots of a quadratic equation are depend on the discriminant. So that is b square minus 4ac, which is there in this quadratic equation here, b square minus 4ac. That is a discriminant. The roots of a quadratic equation are depend on that. If the discriminant value is greater than 0, if the discriminant value is greater than 0, the roots are real and distant. You'll get two roots, and those two roots are different. Then if the discriminant value is equal to 0, the roots are real and equal. And the discriminant value less than 0, the roots are real and imaginary. Okay, so when the discriminant value is greater than 0, then I told the people that you will get two roots, and those two roots are distant. So here root 1 is minus b plus b square minus 4ac divided by 2. Here we are using this plus and minus sign. Here plus and minus sign we are using to get the two distant root. So again, here if the discriminant is equal to 0, then we will get the two roots are equal. If the discriminant less than 0, then the roots are the complex. Here you will get the real part as well as the imaginary part, that is minus b divided by 2a plus I, here minus I. Okay, this is the real and this is the imaginary part. So again here also we are getting two roots. Then we'll go to program. I will explain the code in the Sublime text editor. Then I'll execute here as well, and then I'll take you to to Eclipse IDE. There also I'll execute and show you people. Okay, so here I have created one class called quadratic. I have created one class, and this is the main function. And here I have declared three variables to read the coefficient value a, b, and c. And I have to calculate two root x1 and x2. So here I have taken root 1 and root 2 variable. So enter the coefficient. I'm reading the coefficient term from the user. Okay. So in Java, if you want to read anything from the user, you have to make use of a class called scanner class. Okay. So before using the scanner class, you have to import it. Import java.util.scanner, or you can use the asterisk symbol, that is a star symbol. It'll import all the classes which is there in utility module. Okay, so I have imported my scanner class before I'm going to use this. So whenever make you whenever you are using a class, and when you are going to make use of the function which belongs to the class, you have to create the object of that class. So I'm creating object here by using a new keyword. I have created one object called in. Okay, so scanner in is equal to new scanner system dot in, which is used to read the data from the user, that is from the keyboard. Okay, so next a, so I have three variable already. I have declared a, b, c. In that I'm reading the coefficient value and storing in those variable. So this is the object of a class in dot next int. So I'm reading the integer and I stored in that next int. So like that I'm reading a three coefficient value. Okay, you can store it in this. If you want to read a float, you have to give next float. If you want to give if you want to read the string, you have to give next line. If you want to read double, you can give next double, next long, like that. You can use the functions here. Okay, so next I'm calculating the discriminant here. Discriminant, also called determinant, I'm calculating it. So discriminant formula is b square minus 4ac. So I'm calculating it. Whatever values I have read from the user a, b, c, I'm making use of those values. I'm calculating the discriminant. So based on the discriminant value, if it is equal to 0, or it is greater than 0, or it is less than 0, I'll get the different roots. So I'm checking here, if the discriminant value greater than 0, my roots are real and distant. Okay, so it is all depend on what is the value of the coefficient values you are giving. Okay. Then here the root one, if the discriminant is greater than 0, I'm getting a I'm calculating a root 1 minus b plus. So I'm using the math module math dot square and calculating the discriminant value here. Okay, square root of discriminant value I'm calculating here. Then divided by 2a. This is the formula. Like already I have shown in the PPT. So if the roots, if the discriminant is greater than 0, if the discriminant value is greater than 0, you will get two different roots. So here the first root I'm calculating, root value I'm calculating. Here the second root I'm calculating. Okay, so here, so then I'm printing it. System dot out dot the roots are real and distant. One message to display. And the system dot out dot format. See, there are three ways you can display in Java. One is either you can use a system dot out dot print. You will not get next line. System dot out dot println, automatically it will add next line to a text. And you can use the format statement as well. So system dot out dot format. So here you can use the format specifier, like how we are going to, how we supposed to use in C language, like that. You can use it. %d for integer, %f for float and double. You can use like this, and you can restrict the decimal positions also. So here I'm printing root 1 and root 2. So where are those values? Those values are in a root 1 and root 2 variable. I'm printing it. Okay, so this is if the my determinant is greater than 0, then this is the code. Else if determinant is equal to 0, if the determinant is equal to 0, that means the roots are real and equal. So I'm printing root 1 is equal to root 2 is equal to root 1. Here root 1 is equal to root 2. What is the formula? If d is 0, then you will get just the b square, minus b divided by 2a. If you want, you can see in the PPT. So here, if the discriminant is equal to 0, root 1 is equal to root 2 minus b divided by 2a. Okay, and the next, else the roots are real and imaginary. Okay, if my determinant value is less than 0, if my determinant values is minus, then minus value, then my roots are real and imaginary, that is complex number. So here I'm calculating the real part. Real part is minus b divided by 2a is the real, and the imaginary part is that discriminant divided by 2a is the imaginary part. So I'm calculating separately the real part and imaginary part. Here I'm printing one message. The roots are real and imaginary. Root 1 is equal to, how will you write the complex number? A plus bi, or a plus r minus bi. Okay, so first I'm writing the first one, that is root 1 is equal to, this is the real part and this is the imaginary part. I have added I to this real and imaginary. The same thing I'm printing up by using the minus sign here. Okay, so student, this is the program to calculate the roots of a quadratic equation. So again, now I'll show you the output. You can see here, I'm going to a path. Left. So if you want to execute the Java program, you have to make use of Java C. You have to give, and then you have to give the name of the program. The name of the program is quadratic.java. You have to give. Okay. If there is any error, it will display the error. If there is no error, you will not get anything. You will get like this. Now, if you want to run your program, you have to give Java and the name of the program without extension, quadratic. Okay. So here I will give the value, say 1, enter 2, enter 0. So A value is 1, B value is 2, and C value is 0. So if you press enter, I'm getting the roots are real and distance. So here you are getting the positive value. Determinant is a positive value. So that's why you are getting the roots are real and distant. So here you are getting root 1 and root 2 is this one. Now one more value I'll give. Okay, one more we will see. That is, I'll execute one more time. I'll give A value is 1, B value is -5, C value is 2. I'll give. So this time I'm getting again the positive number. So I'm getting the roots are real and distant, and the root 1 value I'm getting 4.56, and root 2 I'm getting a 0.44. Okay, so we will see one more. So here the A value I'll give 1, B value I'll give 2, C value I'll give n 1. So here determinant I'm getting 0. That means roots are real and equal. So roots are I'm getting a -1. So I'll show you this. We will calculate and see whatever output we are getting is correct or not. So here I'll show you the value of A is equal to 1. The value of B is equal to 2. C is equal to 1. Okay, so I have to calculate the determinant first. What is the formula to calculate determinant? B square minus 4AC is the formula. What is the value of B? B is 2. So 2 square minus 4 into what is the value of A? 1. What is the value of C? 1. So here I'll get 4 minus 4 is equal to 0. So that means determinant is 0 now. So if determinant is 0, the roots are real and equal. So what is the formula? For example, I'll write this. The formula I'll get, the quadratic formula is b square minus 4ac divided by 2a. So here determinant is 0 now. Determinant is a 0. So you will get minus b divided by 2a. So here root 1 is equal to root 2 is equal to minus b divided by 2a. So what is the value of b? Minus b is 2 divided by 2 into what is the value of a? A is 1. So 2, 2, it cancel. So you will get minus 1. Okay. So this is the output we are getting here. See here, the output we are getting is -1. When the roots are real and equal, you have both the roots, root 1 and root 2 will be same. Okay, here we are getting a -1. Okay, next one more, we will see it. I'll clear this frame. Okay. Assume that the value of A we have taken 1, and the value of B we have taken -5, and the value of C is equal to 2. So here a discriminant b square minus 4ac is equal to what is the value of b? -5 square minus 4 into 1 into 2. So here If you do this, you will get 25 minus 4 into 2. 25 minus 8 is equal to 17. So D value is 17. That means D is greater than 0. That is positive. If D is greater than 0, then the roots are real and distinct. You have to get two roots, that is R1 we have to find and R2 we have to find. So what is the formula? We have the quadratic equation formula, that is minus B plus R minus B square minus 4AC divided by 2A. So for the R1, I'll take minus B plus B square minus 4AC divided by 2A. Okay. So minus B, what is the value of B? The minus and the B value is minus 5 plus the square root of determinant I got is 17 divided by 2 into the value of A is 1. So I will get, so plus minus into minus is plus. So the square root of 17 is 4.123, okay, divided by 2. So if you perform this, you will get 4.56. Okay, this is the R1 value. This is the R1 value. For the R2 value, I'll show. For the R2 value, R2 minus B square minus 4AC divided by 2A. Okay. So here, let me clear this. B, the B value is minus 5 and minus B square, this is 17 divided by 2 into 1. Okay. So minus into minus is plus 5 minus, here you will get the value of the square root of 17 is 4.123 you're getting divided by 2. If you do this, you will get the value 0.44. So this is the R2 value 0.44. So we got R1 value is 4.56 and the R2 value is 0.44. Okay. So let us check our output. So here the value, the output, see here, I give 1 minus 5, 2, and we got it. Root 1, 4.56 and root 2 is equal to 0.44. Okay. So student, hope you understood this program. So let me execute this in Eclipse. Open the Eclipse software, go to File, take New, click on New Project. So once you click on New Project, just click on Next, Java project, give the name here. I will give lab Java. Lab.java, click on finish. Okay, so here I got that project. So right click on this, go to new, click on class, create the new class. So here you give the name quadratic. This name should match the name which you are given in your program. The class name and the file name should be same, quadratic. Okay, click on finish. Now I got this by default some text. I'll remove this, I'll paste my text. Okay, so I'll save it, I'll run it. Once you click on run, it will ask you enter the coefficient value. I will give the coefficient value as 1, 2, 1. Okay. See here the determinant for this coefficient are 0. The roots are real and imaginary, and the root and we got it. Okay. Thank you. Hope you understood this concept. Thank you so much.